Okay, so now that we have proportional share working for all processes that did request CPU, they called my request CPU rate. Now we're going to think about, well, what about the processes that didn't actually request CPU? Like, what do we do about those? Now, the spec for the assignment says that you should round robin the remaining time between all the processes that did not schedule CPU. So, like, if one process has 50%, let's do like a quick example. Okay. P1 asks for 50%, and P2 asks for 30%, then the rest have to share 20% in round robin fashion. Okay. There's many ways of doing that. One way could be that you basically recycle your round robin algorithm that you did for for the previous part, and like you have some sort of queue or list or something like that where you're keeping track of all the processes. That way works, and it works just fine. I'm gonna try out a different way, and I'll explain to you guys why I like this way a little bit better. So first, let's just look at a simple example. So let's look at these three processes, P1, P2, and P3. And none of these have scheduled CPU, so we don't know what their request is. Again, let's assume P1 starts here, P2 starts here, P3 starts here. So remember, the little star means that the process starts there. And the little shaded corner means that that process was scheduled. Okay, so at the beginning in quantum 1, because P1 is the only one that's actually existing, we're going to schedule that one. And that's going to be, so it's going to have 100% utilization, right? Out of one quantum, it has run once. Okay? At the second time, we're going to pick P2 because it has 0% utilization, and P1 has 100% utilization. So we're continuing this idea of picking the most unfairly treated one. And we're basing ourselves on utilization here. Okay, so this one will have 100%. We pick this one. And 100%. This one will have 50%, because out of two quantums that it's existed, it has only run once. Okay? Now, in quantum 3, between 50% and 100%, we want to pick 50% because it has the least utilization. So we go ahead and pick 1 again. And now it has 2 out of 3, so that's 66%. And process 2 has 1 out of 2, so that's 50%. Okay? At quantum 4, process 3 comes in. It has 0%. And the other ones have 66 and 50, so we pick process 3. Okay? So that has 100%. Process 2 has 1 out of 3, so that's 33%. Okay? Sorry, that's supposed to be 3. And process 4 has 2 out of 4, and so that brings us to 50%. Okay? At the next one, we look, we have 50, 33, and 100. 33 is our smallest utilization. That's the one we're going to pick. And so now, this one's run 1 out of 2. This one's run 2 out of 4. And this one's run 2 out of 1, 2, 3, 4, 5. 3 out of 5. So that's 40%. Okay? I'm going to keep doing this a couple more times. We pick the smallest. That's supposed to be a 50. There we go, 50%. So we want to pick the 40% because that's the smallest. And so now this one's run 50% because that's 3 out of 6. This one's at 40%, 2 out of 5. This one's at 33%, 1 out of 3. So at the next point in time, we pick this one. Okay? I'll go a little bit faster now. You guys get the idea, right? I'm just doing utilization. And I'm picking always what the smallest utilization is. So then this one, 40%, 42%. And I encourage you guys to try out these examples on your own. They're excellent practice for the midterm. And then we pick this one. 4%, 37%, 33%. Okay, now the smallest one is the 33, so in quantum 10 we would have picked this one. Alright, so something to note here is that by picking the minimum utilization, which is all we were doing, right? We were looking at all the utilizations, and we were picking the smallest one. They round robin on their own. They share the time evenly. And if we look at it, that's true, right? So when we only had two processes, P1 and P2, we ran P1, then P2, then P1, right? So they were kind of like going back and forth. Now we added P3, and then we ran P3, P2, P1. P3, P2, P1. P3, right? And this pattern kind of repeated. So it is basically round robin. And that happens because you're always picking the minimum utilization. So that's always going to get you, it's going to make them share everything kind of evenly, basically. So our big idea for this part of the implementation is picking min utilization means that the processes round robin the remaining time. Okay. Now in this case, I had no processes that requested CPU, so the remaining time was 100% of the time. But I encourage you guys to draw out this example with one or two processes that actually requested some CPU, like 10 or 20%. If you make it big enough, you'll see that whatever time is left over, they'll share between them. The ones that didn't schedule will share between them evenly, and they'll round robin. And the ones that did request still get whatever they asked for. Okay, and so just like before, we had this notion of unfairness, where unfairness meant pick the minimum compute ratio. Here we'll have a notion of unfairness, and we'll pick the most unfair, where unfairness means the minimum utilization. So it's a similar algorithm. Of picking the most unfair. But we want to use utilization. And remember, utilization is how many quantums I've run over how many quantums I've existed. Okay, now why don't we use a compute ratio? That's what we did before, right? With the ones that did request some CPU. We didn't look at utilization. We looked at compute ratio. Well, compute ratio relates utilization to whatever they requested. And here, we have no request. So we can't do the compute ratio because the process hasn't requested anything, right? Okay. Cool. So, with this in mind, what does our code look like? Our previous functions of handle, timer interrupt, and schedule proc look very much the same. Just a small caveat. So I'll just make a note. If you calculate utilization and compute ratio, in handle timer interrupt, remember we said that was a perfectly valid option, and it makes schedule proc a little bit cleaner. Then be sure to only calculate compute ratio for procs that requested, right? Because otherwise you'll be dividing by 0, because the request will be 0. So procs that called my request CPU. And that's really important. Okay, and we'll look at how to differentiate those right now. So, schedule proc. What's our new version of schedule proc? Well, first, we want to calculate utilization. And this, I'm assuming that you didn't already do it in handle timer interrupt. If you did do it in handle timer interrupt, then you don't need to do this part. For all valid processes, regardless of whether or not they requested CPU, because we care about utilization for all of them, right? We care about utilization for the ones that did request CPU, because we use that to calculate the compute ratio. And we care about utilization for the ones that didn't request CPU, because that's what we pick. We pick the minimum utilization. Okay? So once we calculate utilization for everyone, we want to calculate the compute ratio for only processes that requested CPU. Okay? Now, how do we distinguish that? Well, let's look at what a process has. Back in the day, in video 1, we established that processes need certain fields. Here are our lovely fields. And we can use requested, right? Because we initialize requested to 0. But in my request CPU, we set it to something other than 0. And so you can go ahead and use that to figure out if a process has requested CPU or if it hasn't. So we want to use the requested field. Right? And equals 0 means they did not request. Didn't request CPU. Okay, and this looks really confusing, so I'm gonna get rid of that. Just use requested field. If requested field equals 0, that means that they did not request CPU. Okay, so now we have our utilization for everyone, we have our compute ratio for everyone. Again, those first two steps are only if you didn't already do them in handle timer interrupt. Then we want to find the minimum compute ratio, just like before. And the PID that goes along with that. But now we're going to call it min PID that requested CPU. I want to differentiate between the ones that did request and the ones that didn't request. So for the ones that did request, we care about the compute ratio. So we're finding the minimum compute ratio, right? And this is only for processes that requested CPU. Okay? So I want to find what the minimum compute ratio is between those processes and who it belongs to. Cool. Once I've done that, I want to find, and remember this is the notion of the most unfair. So, most unfair out of processes that requested CPU. Cool. Now, I want to find my minimum utilization and the PID that goes along with that, and I'm going to call that minimum PID that did not request CPU, so no request CPU, okay? And this is for processes, only for processes that did not request CPU. Okay? And then this process is going to be the most unfair out of all processes that did not request CPU. Okay. And then at the beginning, we might want to initialize these PIDs, min PID request CPU, and min PID. We also want to initialize min compute ratio and min utilization. No request CPU. And I always like to initialize them to -1 when it comes to PIDs. Because if I initialize them to -1, and then I mess up, and I just return whatever the default value is, the default will be -1, and my kernel will scream in pain, and so there will be an error. So I like to do that so that I can catch errors quickly with my algorithm, right? This should always be set to something else, so I initialize it to -1. And we'll see that that's useful later on. Okay, so now we have the most unfair out of the ones that requested CPU, and the most unfair out of the ones that did not request CPU. So the last thing we need to do is pick between the two. The two most unfairs. How do we go about doing that? Well, there's a couple cases we can look at. Here's one. If the minimum compute ratio, the one belonging to the most unfair process out of the ones that did request, is less than 1, then that means that that process has gotten less than what it asked for. Remember from video 1. So if that process has gotten less than what it asked for, we always want to pick that one. So we want to pick the process that goes along with that minimum compute ratio. So min PID that did request CPU. So this is a process that requested CPU and hasn't gotten all the CPU that it wants. Okay? And so we do this because we always want to give priority to processes that requested CPU. Okay? What's another case? Alright, what if, so if the compute ratio is greater than or equal to 1, that means that the most unfair process has gotten either exactly what it asked for or a little more. So that means that all the processes that requested are pretty good. They're pretty happy. So now we can go ahead and look at the ones that didn't request CPU. But what if there wasn't any that didn't request CPU, right? We never went into this part. We never had to find the min utilization because all of our processes requested CPU. Then this PID will be equal to -1, right? Because that's what we initialize it to. Okay? If the PID equals -1, that means that all processes requested CPU So we want to obviously pick the minimum out of the ones that did request CPU, because all of them requested CPU, right? So that's min PID that did request CPU, since there is nothing that didn't. Okay, cool. Otherwise, then we can go ahead and pick the one that did not request CPU, the most unfair out of those. Right, because at this point in time, we know that the processes that did request CPU they're all pretty happy, because the compute ratio is greater than or equal to 1. So they've gotten either what they asked for or a little more. So we can go ahead and let the other ones round robin. And remember that the round robin happens because we're always picking the minimum utilization. And that makes them round robin, just like the example showed. Okay? So just something to keep in mind. You have to remember. Oh no, what did I do? Okay. Remember that you have to increment running time for the process that you picked before returning it. Because remember that if we picked it, that means that it's going to run for one more quantum. So be sure to increment whichever one you did pick. Be sure to increment running time. Just +1. Okay, cool. And with all this, you should have a pretty good idea of how to get proportional share working for processes that did request CPU and processes that did not request CPU. And that's the end of this video series.